This one, lesson 29, is a very important lesson about fractions, which are parts of a whole. We're going to be talking about multiplying them and reducing them. Let's first think about what multiplication means. Okay, even before any of this is talked about, if I say, I've got a 2, right? 2 means I've got, two things. All right, what if I say I want 3 of those 2's? 3 of 2. Well, of then is really saying we need to multiply 3 times 2 because 3 of these means I have another couple, and another couple adds up to 6. 3 of 2, 3 times 2 is 6. All right, now what if I say I want half of 2? We know that's going to be 1. What operation gets us there? Let's try multiplication again. Half of 2 is 2 over 2 is 1. So of really means to multiply. And if I now take a half of a half, so a fraction on each side, what do we get? They illustrate it nicely for us here. We first have a half, and then we want half of that. And you see it ends up being 1/4. So what we do is we say a half of a half. 1 times 1 is 1. Remember, with multiply, you also multiply the denominator. It's already reduced, 1/4. When we multiply fractions, multiply the numerator and multiply denominator, please. How we doing? How about half of 3/4? Half times 3/4. Again, no reducing to do. Different denominators, but those are easier in multiply and divide, which is great. How about 3/4 times 2/4? Okay, they even illustrate this for us a little bit. Well, first, simple multiplication. 3/4 of 2/3. Multiply across 6. Multiply across 4 times 3 is 12. And you'll see right off the bat 6 goes into 12. So we can reduce. As you can see in this figure, they illustrate a circle divided into 12ths. We count up 6 of them. The shading really is a half here. Use fraction manipulatives to show this. Fun thing to know how to do if you're ready for it already. Little extra work. To reduce the end, we could have saved ourselves time and saw that 3 across is here at 3. 3 goes into 3 one time. I see a 2 across that goes into 4 once, leaving 4 as a 2. And then I multiply 1 times 1 is 1. 2 times 1 is 2. And look at that, we didn't even have to do any of this nasty 6/12 business. Hold on to that, we'll learn more about it another time. How do you change 8/3 to 2 2/3 here? How would I do that? Because we're going to need it in this lesson. Think about it. Let's multiply a big whole number by 2/3. I want 4 of 2/3. So you're thinking about like 2/3 being added 4 times is really what that says. Or we could just go 4 times 2/3. 4 is really 4 over 1. Any whole number is that number over 1, right? 4 times 2 across the top here is 8. 1 times 3, 3. How do I find this? How do I get to this? 8 divided by 3 goes in there twice, leaving me with a remainder. 2 goes over the divisor as a mixed number, 2 2/3. We're doing great. These are really important skills. If you're feeling pretty good, you are doing wonderfully and you're going to feel successful. And if you don't, ask questions so we can get you feeling wonderful. 3 pennies placed side by side. Diameter or distance across from one end to another is 3/4 inches. How long is the row? We could add up 3/4 3 times. You got common denominators. It's not that hard. But let's start practicing our multiply. 3 over 1 times 3/4. Go across the numerators. 3 times 3 is 9. 1 times 4 is 4. 9 divided by 4 will come out to 2 and a fourth. We can reduce fractions by dividing numerator and denominator by a common factor, like we did with 6/12. It became a half. Without using manipulatives, you can know that because they share the GCF of 6. So you actually divide it, top and bottom, by this factor. This means the same thing as 6/12, but with smaller numbers, more proper that way. Rewind and rewatch that if you're unsure what I just did. 6/12 and a half are considered equivalent, meaning they are worth the same value. We divide both numerator and denominator by a GCF, and we pick 6 because 2 or 3 or 2 would have taken too long. We would have had to do that one again by 3 to finally get to that half. So GCF saves us that time. How about 8/12? What do they share as a GCF? I can divide top and bottom by, let's use 4. Because 4 goes into 8 twice. 4 goes into 12 6 times. No, 3 times. So 2/3 looks reduced. Very nice. They said they're going to show us 2 methods. Let's check that out. Dividing by 2 and then having to do it again, or just doing all 4 at once. I'd pick that every time. 2 times 5/12, example 6. Let's try a red marker this time. We can do some of that cross-reducing if you want. Make this a 1, make this a 6, and you get 5/6 right away. Or you could do the longhand, get 2 times 5 is 10. Of course, 1 times 12 is 12. Divide them both by the GCF of just 4. How about example 7? We're almost done. 8 boys, 12 girls. What's the ratio of boys to girls? I'm guessing we'll have to reduce them. Boys to girls, 8 to 12. Let's show it as a fraction, 8 to 12. And then we've got to do that same one we had before. Divide top and bottom by 4. That GCF. Simple enough, I hope. Hope you're feeling good. This is good. These are good things. Pick a multiply in the first 3. Pick a multiply and convert in the next 3. And pick another, how about just J? So pick one from the first group, another from the second group, and letter J, leaving us with 3 total problems to do for